In the modern wilderness of Athens, Wisconsin, we observe 3 cells in their natural habitat fighting about like a bunch of imbeciles. Luke Marginski is here with us to capture these specimens for science.
We're going to see if we can get a closer look now. We have to move stealthily and quietly. We'll creep up to this well-placed truck around the backside. They haven't noticed us yet. Alright, I'm going to pick out the weakest one on 3. 1, no! No!
Go, 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 go! Get the cells! Oh!
I got one!
We got one, we got one, we got one! Take him down, take him down! Alright,
You stay up.
now we have to take him back to captivity and
to
study him for
captivity.
science.
And now for something completely different.
And here we see the plasma membrane. It defines what comes in and out of the cell through the process of selective permeability. It is gelatinous and very fluid, and has a phospholipid bilayer. Here comes a water cell that comes and passes very freely through the cell without any problems whatsoever. However, some substances, like sodium salt and even viruses, come in with very, very much difficulty. Thank you, plasma membrane.
And here is Mr. Nucleus, CEO of all cell operations. He controls all basic cell functions and contains DNA.
Pretty much the brains of the operation.
And here we have our everyday and normal nucleolus. The process of this cell organelle is to create ribosomes, as you can see here. And there it is! Fine and dandy. And here we have our ribosome coming off the nucleolus that is, and he is making his maiden voyage to the endoplasmic reticulum. And then they connect, making the endoplasmic reticulum rough. The endoplasmic reticulum is the site of chemical reactions within the cell and is a series of highly folded membranes. Here, the ribosome makes its precious proteins and begins its process of maturity. And here we have our rough endoplasmic reticulum. It is giving the proteins it has created to the Golgi apparatus, which begins to modify and package them into the final product, and then gives it off to the other parts of the cell for usage. And here is our everyday part of the cell. It needs its proteins. Here it comes. And it uses them. Fiber. Oh.
What in the name of the Queen are they doing?
Why, you see, Mr. Birmingham, they are the cytoskeleton. They give vital support and structure to the cell by the use of microtubules and microfilaments.
Not my problem.
Fine, be that way, bloke. And here we have our everyday Golgi apparatus. As you can see, he is worn out by age and biogenesis. Something must be done about him. As you can see, Mr. Lysosome has taken care of him with his digestive juices. Nothing remains of him. And here we have the cytoplasm. It is a gelatinous, fluid-like substance that holds all the cell organelles in suspense. And here we have the cell digesting some of its well-needed nutrition.
Oh, I'm stuffed. This is going in the trash. It's not like I expect a vacuum or anything.
Nobody expects the vacuum! No one wastes anything in the cell!
Quite right, vacuole. See, the vacuole is a sac that holds vital food and nutrients, and water, for that matter, that the cell can use at a later time.
Wow, it's the vacuole.
Nobody wastes anything here. Always happy to help, mister.
Another situation averted by Mr. Vacuole. And here we have the mitochondria, the powerhouse of the cell. It produces the energy required through the food and proteins it has acquired through all the processes that we have talked about before.
Let's go, Luke. You can do it. Yeah, you can do it, Luke. Get it up. Get
As you can see, the mitochondria's work is very important to the cell and produces the energy required.